Good afternoon, everybody. Thanks for hanging out to the last show here, and everybody have a good time so far today? A lot of good information? Good. Hopefully I don't ruin the streak then. So, as Clint said, my name's Eric, and I'm with Stratus Technologies, and I think we inadvertently stumbled on a theme where a lot of us are overlapping content in terms of talking about how the plant floor or OT side of the house is merging with the back office or IT side of the house and how those two worlds are bridging. And that's kind of what I'm going to talk about today. My presentation has kind of got several sections. First, I'll at least explain who Stratus is so you know how I view the world and where we're coming from. Secondly, we'll talk a little bit about the historical background on what we're referring to with this OT-IT divide, just to sort of frame that discussion. Then we'll explain our products and service set and how we fit into that larger picture and how we work with clients to implement a IT solution that's made for the OT world. Okay? I encourage you, if you have questions or thoughts, feel free to ask, because interactivity is better, and if I don't move that water, I will undoubtedly fall. So with that, Stratus. Who the heck is Stratus? We're a 36-year-old company, founded in 1980, so older than Dell and some of the more commonly known names. I won't read the slides to you, but I'll point out several facets that I think are important. On top, it says the only failure avoidance solution, or always on. We contrast very much our services and our solution set with something that's known as high availability. And in a high availability solution, it might be a cluster, it might be multiple computers with some failover. There's always a concept of a failure and then a recovery from the failure. So the old Windows blue screen of death, for instance, or applications go down, HMI screen disappears, and then there's a structured recovery. With the Stratus solution, as I'll explain later, we avoid it altogether. So even if there's a failure of a hardware component, your HMI screens never blip. And I'll explain how we do that. And then the other bullet point here, the last one, is the IT solution built for the OT world. I alluded to that already. That is a key fundamental characteristic of our company, of our solution, and quite frankly of this talk. These two worlds have sort of lived in parallel and separate, and we kind of think that our solution brings them together in a way that is quite favorable for both sides of the coin. And then lastly, I mentioned 36 years old, over 21,000 systems installed all over the world. And these are some of the logos. You know, I won't gloss too deeply into the logo section, but I will say this. You know, 36-year-old company, and we're not a household name. Why is that? Well, we are a household name in certain industries. In telecommunications infrastructure, Stratus is really the default for switching stations and things like that to keep the telecommunications infrastructure up. Public stock trading all over the world. Public stock trading is running on Stratus servers and all over the place. One of our biggest customers is we're not allowed to use their logo or their name, and since I'm being recorded, I certainly am not going to violate that. But it's a company that if you have a credit card and you don't leave home without it, you're using Stratus. There's also another company, similar situation, we're not allowed to use their logo or their name, but if there's a park where a mouse lives, and all their transactions are also running on Stratus. So we've got a really nice legacy of customer base, and again, just so you understand where we're coming from. So this information is kind of, I wanted to set the stage with this historical, and the first bullet point there is something that I think escapes people's grasp, which is that the original technology, automation technology, wasn't computers and things of that nature. It stemmed in the early 1900s from the Industrial Revolution. So your guys' world, the OT world, is really what the original technology was. Computers didn't appear till much later, right? So in the 60s, 70s, computers came around, and all of a sudden the word technology gets associated more with that world. But what we developed was these two separate parallel worlds, where the IT characteristics are data center based, centralized, very clean environment, very structured environment. They're operating on a 3 to 5 year window of obsolescence versus plant floor, where you're expecting things to last 15 to 20 years, right? It's not swapping out equipment every 3 to 5 years. And historically, we're talking about a single vendor approach. So you probably have, for your DCS systems and things of that nature, it's a very one solution that's implemented and maintained from that vendor. And again, historically, the IT guys didn't touch the plant floor. That started happening when Ethernet made its first appearance, right? When Ethernet first came out, it wasn't good enough to be running on the plant floor, but over time it got better, and all of a sudden IT appeared on the plant floor. So one of the things I want to talk about is sometimes it sounds like we end up bashing the IT world, and I want to make sure that's not what anybody thinks is happening here. Both roles, IT and OT, have their place. They both have different mandates. They both come from different environments, different cultures, et cetera, but they both play a real important part of keeping this enterprise running. And so I want to acknowledge that right up front. So these are some of the core characteristics when we talk about IT. I'll mention on the bottom, speed, agility, and performance. That is what they're measured on. That's their key performance indicators. And so that is not necessarily, we're going to contrast that with the plant floor and the OT environment. And again, these guys, some of them are called software engineers or network engineers, but they aren't traditional engineers that we think of when we think about electrical, mechanical, et cetera. And again, they come from a world where they take lots of different vendors' equipment. They take hardware, software, peripheral devices, almost like a Lego kit, and they put them all together into these complex solutions. And they're great at that. That's what they're trained to do, right? Now, conversely, in the OT world, it's not just operating with data, it's physical things, right? And it's obviously what's happening in the plant floor, as I mentioned, true engineers. And the goal is not to be tweaking and maintaining and administering all the time. The goal is set it up, let it run, get whatever you're supposed to be getting out the other end of the facility using the inputs from the other side. And again, long deployments, 15, 20 years. And instead of the KPIs that we talked about for the IT world, in the OT world, it's reliability, integrity, safety. These are the things that we think about on the plant floor, right? Is this resonating a little bit? Okay, good. So we got this idea of convergence, right? What is driving this? Well, I talked about some of the standard protocols like Ethernet, and then even TCP and Modbus, and some of the technologies like virtualization and hyperconverged infrastructures, and even in the PLC world, things of that nature, right? And now you've got the industrial Internet of Things. It's all over. You can't go 3 seconds without hearing about the Internet of Things. But it is real. Are you guys, anybody deploying some of the more sensors and monitoring more systems based on that Internet of Things concept? Typically, I get folks that are starting to implement that sort of thing. And the flip side of that is, so you've got all this data, you're gathering all more data, right? And it's trying to feed it up to the back office, right? Because they want to analyze this data. And at the same time, there's a concept called big data. And what that is taking all this information coming from all these sensors and coming from all these other inputs and analyzing it and doing something with it and making it actionable. And those two things are happening at the same time. We're seeing it in our customer base, and I was getting some nods here. The other seminar that we did the other day, same thing. And it's all this data, and it's important because it's being used up at the corporate level. And we'll talk about some of the benefits here in a second. The other thing that's driving all this need for data is the regulatory environment. Anybody facing more reporting in their world? I mean, this is something we see all the time. You know, we mentioned FERC, NERC, and EPA, and all these sorts of things. And obviously, that is driving the need for data as well. And the data's got to come from the plant floor, right? And it's got to be fed back to the corporate network. And so that's where this convergence takes place. And of course, global competition is always a factor. So what are some of the benefits? Why are we going through all this? I mentioned, obviously, you're trying to get this data for actionable information. You want it in real time. They want to be able to accurate reporting, trends, thresholds, and just a more active participation in the manufacturing process. And whatever that is process that you guys are running, you want to be able to understand what's happening, and that's what's driving this. Obviously, risk reduction, operating costs is always a factor. It's trying to eliminate waste and reduce the cost. Customer satisfaction is something that at the end of the day is hopefully a part of this as well. And again, a lot of the policies and security that the IT group has implemented is now necessary on the plant floor, and vice versa, because each world has had a different approach to security, right? So if you're connecting these two worlds, it needs to be acknowledged, it needs to be standardized. So what are some of the challenges? The first thing to know is, despite the fact that I'm coming here from a computer vendor, it isn't the technology. The technology is never the challenge. The technology is honestly the easy part. But the skills, as we talked about earlier, the skills from the OT and IT side are completely different and non-overlapping. I was talking with somebody at lunch, and he said that in his facility, they've hired somebody that's whole job is sort of to bridge that gap because he has an IT background and also has an OT background. Is anybody putting in place folks like that in their plants? We're seeing that. Oh, you're him. Okay. All right. Good. Yeah, and we're seeing that all over the place. And even from a partner level, a lot of my partners that we sell through are starting to employ guys that have a little bit more IT background because, again, they speak different languages, they have different skill sets. And culturally, very different cultures as well. As I mentioned, data center IT, you're used to a clean data center, a very pristine environment, and obviously plant floor, it's not always the case. Obviously, doing more with less is always a challenge to all these things, right? Everybody's trying to be as productive as they can, and companies are trying to keep their costs low, so that's always a factor. The fundamental different charter, we talked about that. I mean, each group is measured on different things and comes at the world from a different place. In the IT world, taking a Windows patch and sending it down through a system is not going to cause anybody too much aggravation. But if you're running your SCADA system and you need to be able to monitor your systems, that could cause a real problem. And then if we're implementing a project, so we're going to talk more about sort of a project approach now when we sort of move forward here, who owns it? Who owns it? And that's a fundamental thing that I think is lacking when we talk to our customers and work with Logic and folks like yourselves, and we start thinking about these projects. We're starting with the plant because you're guys that are owning the HMI and owning the historian, and then the IT group comes in at some point. But very often there's a little bit of hand-wringing and discussion about who is actually going to own this thing at the end of the day. So the good news is there's a solution. Here it is. All you got to do is follow this. Everybody familiar with this? It's also kind of known as a Purdue Model. I'm joking a little bit because obviously it's a nice framework, but this doesn't really help you do anything, right? This is not an actionable plan. But somebody has thought about this, like where is the different segments, and it's actually a useful chart to think about where different processes lie. But in reality, here's what we like to talk about. We're thinking about implementing, for instance, the Wonderware. We're implementing an HMI, historian, et cetera, or maybe we're going from a traditional environment where we've got multiple separate servers and we're going to now virtualize. That's something that's very often part of the project. So the idea, first of all, is define success. Is success implementing this in the cheapest way possible? For somebody in your organization, that's probably the goal, but probably not for anybody in this room. And then, of course, the idea is capacity, skill, willingness for IT to support the plant floor, and all those things are relevant, right? Because they may not have the capacity due to downsizing, et cetera. They may not have the skills because of the non-overlapping nature, and they may not want to be involved down there, okay? And then conversely, it may be the opposite. Or the capacity, skill for OT to own the IT infrastructure on the plant floor. And one of the things we're going to talk about is that we believe that our solution enables OT and plant floor and controls engineers, et cetera, to own an IT infrastructure that supports their world in a way that the IT group is also comfortable with. But again, you're going to have some connective fabric, right? If you're feeding that Internet of Things, you're feeding that data up the ladder, there's got to be some way for that data to get there. And then, again, impact of downtime. Downtime, when your server is down for your emails for a few minutes, few hours, it's a nuisance, but it's really not costing anything. But I've been talking to several folks today where even a moment of downtime can really have a hazardous effect, either to safety, data accuracy, or just productivity. And again, it's a key factor that is different from an typical IT way of thinking versus a typical plant floor. And then the impact of the recovery, that's the other part. If you have downtime, it's one thing to have a structured way to recover over to another server, for instance, or another solution, cloud, or whatever it may be. But then how do you get back to your normal operating mode? That's something that is very often overlooked, okay? And we'll talk about that a little bit. So, and again, life cycle goals, I'll beat that one to death, but typical standard servers and typical IT implementations, they are really trying to refresh the technology that undergirds it every 4 or 5 years. And again, that is typically not a life cycle goal for anything you're implementing on your plant floor. Make sense so far? So we're talking about availability then and downtime. And we have several options. One is we buy a server and we put it out there, and occasionally something's going to go wrong because servers are mechanical devices. And you're going to call the vendor and they're going to show up in an hour, 1 to 4 hour service window, and they're going to fix it, right? So what happened is they came up with this idea of clusters. And this is kind of your IT-centric solution. And clusters their word, not mine. But basically what you're taking here is multiple servers, and typically there's some external storage, and it's a complex solution, and it works in many environments. But again, it's an idea of fail and recover. So your software fails on one system, and it's structured to recover on another. A lot of people implemented virtualization as a solution for uptime. Anybody running a virtualized environment already? A few? Okay. So virtualization on its own provides some benefits, a lot of benefits, but it doesn't provide a lot of uptime necessarily without a lot of man interference, a lot of administration. And it's a common theme to think, well, we're going to virtualize because that gives us uptime, but virtualization on its own really doesn't provide that. So here's what we do. This is our approach, and this is, I know a lot of folks wanted to get this, so I appreciate you bearing with me on the historical information, and now we'll get to the meat of the Stratus solution. First of all, we start with, again, we're manufacturing a server. It sounds like an IT product. Again, I'll make the case that it's more designed for the OT folks, but we start with industry standard components. So you've got a CPU from Intel, we've got memory, we've got disk storage, et cetera, and we're purchasing from the same vendors that everybody else does, Dell, HP, et cetera. We all buy from the same underlying manufacturers for this stuff. We do a much more rigorous testing process because everything for our company is about uptime. Remember beginning when we said 21,000 systems, we've deployed those all over the world. We have 500 employees all over the world. Only thing we do is support uptime. We have 3 products, small, medium, and large version of this server that I'm telling you about. So everybody in the company is laser focused on uptime and making sure that applications don't fail. So we take those industry standard components, and the first real point of differentiation besides the testing that I just alluded to is this box in the middle called the Automated Uptime Layer, or AUL. And you'll see that it says fault detection and isolation. So the fault detection part speaks for itself, right? It's monitoring over 500 points within its system and looking for anything that it can spot that might cause software to fail. And we're talking underlying memory and disk usage, and even ambient room temperature, HVAC systems going out, and things of that nature, fan speed, and power supplies, and you name it, over 500 points. So that's the fault detection. But then the neat part is the isolation part. What that means is, if we discover something that is failing or has failed, we're going to take it offline and get it out of the picture so that it can't cause any harm to the software. And the reason that we can do that is that we've doubled everything up. So there's 2 halves to a Stratus server. Each one of them has all the components that you would find inside of a server. So each has its own CPU, memory, storage, etc., and each has its own AUL. And so each one is monitoring his half and also comparing notes with the other, just again to make sure another level of redundancy. There's no single point of failure in a Stratus server. Everything is doubled up. And the way that they are linked, this is the proprietary, this is the secret sauce, this is the thing that Stratus created in 1980 that nobody else in the world can do, is we lockstep the CPUs. What that means is that the same software code that is being executed on the top is being executed on the bottom at precisely the same moment. Nobody else in the world can do this. True fault tolerance. This is executing in the same server, 2 different places at the exact same time. And then on the back, the storage and the external connections to the network are also teamed in a way that, again, there is no single point of failure. There's nothing in a Stratus server that individually could fail that would cause your software to disappear. So here's what it looks like. And you're going to see, I call it 2 halves of the system. The other thing that we refer to them is CRUs. So CRU stands for Customer Replaceable Unit. You see there's some thumb screws there on the top of each of the halves, and there's some things that you slide out. So basically you can pop out a hard drive. There's 8 hard drive bays on the top and 8 on the bottom. And then there's the entire Customer Replaceable Unit. And we'll talk about that in a second. But again, and this is terminology that we're careful about, even though we've got two sets of hardware. It is a single server in every way, shape, or form. It is running a single copy of software, again, on both. So from a licensing perspective, you're licensing my server the same way you would license any other single server. You don't need to buy anything special in terms of licensing. And from a network management perspective, the IT guys will love this. It's a single IP address, it's a single MAC address. It is managed in every way, shape, or form, just like any other individual server. No complexity to the management either for the OT guys or the IT guys. So what happens when something fails? We're in a unique position here. Normal server, when it fails, somebody's got to pick up the phone or send a call, or somebody needs to reach out to somebody else to come fix this thing. But because our server is still running, the server can place its own support call. So that's what happens. So if CPU fails, remember the AUL isolates that thing, right? And it sends an automatic system, process is initiated whereby it's ordering a replacement part. Now typically that call, that phone home, comes directly to us. We also operate in environments where it doesn't come directly to us, or it notifies us as well as some other third party. Could be yourselves, could be the IT guys, could be a vendor that helps support you. But somebody needs to know that something has failed because we need to replace it. So what happens is we send out for overnight delivery a replacement. Remember I called them customer replaceable units originally, the crews, right? So the only two things that you'd ever have to replace on a Stratus server would be a hard drive. Again, there's 8 on the top, the white things, and 8 on the bottom, or the entire crew. And we do that because we don't want our customers to have to understand how to plug memory DIMMs into motherboards or screw in power supplies or anything like that. Basically, anybody that can turn some thumb screws and slide a device out, slide in a replacement, can handle these replacements, these physical replacements. And the important point is the system that resynchronizes itself without any other intervention. So nobody needs to log a single keystroke. Nobody needs to call somebody and say, okay, now I put in the new hard drive, now fix it. The system handles that all by itself, automatically. And again, normal processing throughout. So your HMI screen hasn't blipped, nothing's failed. If you were running a Netflix video on it, you wouldn't have noticed any of this. There wouldn't have been any blips or anything like that that would have happened during this entire process. And so when we get deployed in a control room, typically off the plant floor. We're not in the data center. We also get deployed in all sorts of interesting places. We get deployed in oil rigs and pumping stations for pipelines, whether it be gas or oil. And again, we are deployed in the OT environment. And so when I'm advising my customers, who are folks that are controls engineers and things of this nature, I think it's an error for everybody involved, to get back to the original, this idea of bridging IT and OT, to just say servers aren't my thing and hand it off to the IT guy. And it's an error for them to say servers are my thing, so I own it. Because you need to think about this from a whole new perspective at this point. The other thing that we also, that we get a lot, and this is the other piece to the puzzle, by the way, I guess I skipped this. So this is that phone home. We could also generate a local email, and we also now have an integration where it'll come up right in the HMI. And this is for facilities where there is literally no connectivity. For instance, Arnold Air Force Base in Tennessee is one of my customers. And despite the fact that our phone home is extremely secure, they don't want to hear about it. They're testing new weapon systems and things of that nature. So they get the alarm right in the HMI, and then they have to actually call us or send us an email, and then we're aware. But more typically, even some of those large customers that I mentioned up front, typically they're connected directly to us. But we just have other options is the main point of this. And the other piece to the puzzle, this idea that creating an IT infrastructure that is designed for the plant floor it's more than just a server, right? When we're talking about implementing these solutions, there's more pieces to the puzzle. There's more network infrastructure. There's the software itself. We always get the question, well, this is great, Eric. You got this cool server that if a hardware failure occurs, I'm protected. But what about the software? What if that fails? So what we did is we've just had this product called Sightline Assure that we brought into the picture. And it helps to manage, it gives you a window into the other network devices and how they're operating, and also the software applications themselves. And this is a neat solution that is, again, this sort of monitoring and network management and things of that nature, there's a lot of those types of solutions that are very complex, designed for folks who go through months and months of training to learn how to use them, et cetera. Ours is designed so that a controls engineer can look at an easy dashboard and understand what's going on with this system. And I'll show you that in a second. But these are the features that it does. You know, again, you can set up critical thresholds so you understand if you're reaching your limits for memory or storage, things of that nature. You can understand if any of the virtual machines or any of the operating systems are having problems. And here's the neat one. You can actually set up a structured restore if a virtual machine dies for some reason. If you have a software operating system that dies, you can actually set it up so that it automatically gets restarted. So again, my server is protecting you from any sort of hardware failure, and now we've added in a level that's protecting you from software failure as well. And again, the idea is that anybody, any controls engineer with about a half hour of training will understand how to use this. Very simple dashboard. You got operating systems, applications, and hardware. Checkbox, okay, that probably means it's okay. Yellow, that must mean there's a problem, right? Very simple to understand. And so again, this is a little more granular now. Again, you've got checkboxes, you've got lots of things that look good. Whoop, yellow flag by the domain server. So that you may have the skills, or the people who are running these systems may have the skills to actually execute the solution. Very often they won't, and that's when you're going to need to go get somebody that understands what the implications of that are. But the point here is it's giving you a window into all these things as well, making it a plant floor type solution that can be monitored and maintained without somebody that is well-versed and trained in all the various technologies that underlie it. We typically run in a virtualized environment. We don't have to, but typically companies run our servers with virtual images on them. And the idea is, you know, we hand out these Virtualization for Dummies books at my table, if you saw that. But the point is, to the audience like this, is you don't have to understand the virtualization. We take the complexity out of the way for you. And so this is another part that will appeal strongly to the IT guys. We are really kind of unique. You know, I just mentioned nobody else can do what we do with the lockstepping. We also have a unique relationship with Microsoft. Because our servers are still working even after something fails, we can do root cause analysis in a way that no other vendor in the world can. So we are one of the only companies in the world that has Microsoft source code that we can make fixes, hot fixes, and feed them back to Microsoft and say, hey, here's something that's a flaw that you guys need to fix. And then they'll, of course, check it and double check before they release it into the rest of the world. But obviously, we're certified on all the major vendors. And so when we're talking about virtualization, it could be one or more or all these applications, all these wonderware applications. The ACP, if you were in here for the previous session, the ACP session, ACP is typically a part of these things. It's a really neat solution. If you didn't get to hear Jamie talk, I recommend you stop by his booth. But this is very typical. And this is what it looks like for those who aren't familiar with virtualization. You've got basically separate virtual machines running a specific operating system and then a specific application on top. And one of the neat things about virtualization is you can have different operating systems operating next to each other and they don't interfere in any way, shape, or form. So again, this is that idea that if you're going from the traditional server sprawl kind of separate servers doing separate things and you're considering virtualization, this is why you want to think about something like what Stratus brings to the table. If you lose a single server in the left side, you've only lost a single application. If you lose your server and you're virtualized on a single server, you lost everything. And so here's the alternative. If you say, okay, we're going to virtualize, and we're worried about availability, we want to make sure that our applications are always available. This is that cluster idea on the left side. And if you're using VMware, their best practice dictates at least 3 servers, but I know a lot of folks try and get by with 2. And so you're going to have multiple servers, you're going to have multiple high-speed switches, and then an external storage device as well. And again, you're still going to get, this is VMware's figures, by the way, not mine. They're still going to average about 4.5 hours of downtime a year. And what we have is we eliminate the need for the second server, the multiple licenses, all that storage, and we're actually providing a higher level of uptime across all those 21,000 systems. We're at 5 nines plus, and we constantly monitor it, and we actually publish the data on our website, by the way. And so honestly, I think some of these, we talk about availability. I think my marketing people have shortchanged a little bit the VMware solution. I would probably put that availability threshold a little bit higher. And then from a cost complexity perspective, I think they nailed it. It's certainly a very complex. It's something that, if you're a VMware certified and you understand everything from an MIS background, you can build one of these and maintain it. But you better be somebody that has that background. And versus Stratus, again, it's continuous availability. The availability threshold, I argue, is perfectly aligned here. Cost and complexity, certainly from a complexity side, we're very easy to install and administer. And then from a cost perspective, it's very, very competitive versus a cluster, and versus a single standalone server. Obviously, we're going to be more costly than that. And that's kind of the end slide that summarizes the value proposition. Again, you can see, I think this is a good way to see how easy it is to slide out the bottom crew. And I think that's all I had. Yeah, and again, Logic is a great partner of ours, and so you can certainly get at us through them. But I do appreciate the time and attention. Hopefully you guys got some value out of this. Again, thank you very much for the time.